Welcome to Unacademy, the largest online e-learning platform. Welcome to Unacademy semester exams. We were dealing with network analysis and transmission lines, two-port networks. The next sessions will be on two-port networks, and the topic for today is impedance and admittance parameters. So this is lecture 10, crash course. So please do inform your friends, ask them to join the session, and we will have much more discussion on this. So before that, let me tell you about myself. I'm Vai Shravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services and also cracked GATE. Let me tell you about Unacademy Learning App installation procedure. Type Unacademy Learning App, click on this install. Then if you're opting for GATE and engineering services, click on this, then click on this plus and click on get subscription. You have plus and iconic subscriptions wherein you'll get a dedicated mentor for your preparation, and you can use my code YSK10 to get the maximum discount of 10%, and then you can click on this proceed to pay. And you have many payment options like debit card, credit card, EMI, UPI, wallets, net banking. Using any of these methods, you can get subscription to Unacademy, the largest online e-learning platform. Right? So let me also tell you about this Evolve for GATE 2022 and Ascent for GATE 2023. This is for the students who are preparing for GATE 2022 and 2023. You can join these and get subscription to Unacademy, and you'll have the top educators teaching you. Raju, good evening. So in Unacademy Combat, there are, you can see these students who have cracked combat and also won prizes, first prize, second prize and third prize. So you can also even compete and win them. So let me tell you about that Unacademy Combat. It is India's largest fortnightly competition for GATE and best questions by the best Unacademy educators and challenging questions curated by the best Unacademy educators. You'll have questions guaranteed to keep the test engaging, challenging as well as fun. So it's a super fast and fun with real-time ranking. See how you rank against others with a live leaderboard after each and every question. So compete with the best, know where you stand among the other contestants, and you'll get a detailed video solutions by the top educators. Get in-depth video solutions right after the contest. So you can compete, crack and conquer. You have score, you have leaderboard, rating and awards. So you can compete with the best and win amazing prizes. The first three ranks will be receiving 3 months Unacademy subscription or an equivalent Amazon voucher, and rank from 4 to 50 will receive 500 rupees worth Amazon voucher. So Unacademy Combat is compete, crack and conquer. It's India's largest fortnightly competition for GATE. Challenging questions curated by the best faculty, super fast and fun with real-time ranking, compete with the best. You have the detailed video solutions, and you can also win exciting prizes. That is from ranks 1 to 3 will get 3 months subscription to Unacademy or an equivalent Amazon voucher, and ranks 4 to 50 will receive 500 rupees worth Amazon voucher. So what are you waiting for? Enroll for free. The next combat goes live on December 29, 6 p.m. tomorrow. You can register now. You can use the code crackgate, or you can also use my code YSK10. So competition format is something like this. It has 15 questions and 60 minutes. So 4 combats and 3 cohorts. So relative scoring based on the speed and the accuracy. Right? So enroll now in Unacademy Combat. To participate in Unacademy Combat, sign into Unacademy Learning app, which you can get it from the Google Play Store. You can use my code and you can win amazing prizes. So coming to the topic for today, before this, let me also tell you about this Evolve and Ascend once again. So evolve for gate 2022. Starting batches evolve for gate 2022 and ascent for gate 2023. So it starts from the December 28th. We have the top educators from Unacademy. So hurry up, get subscription to Unacademy. So that was about the evolve and ascent. So today's topic for today is impedance and admittance parameters. The topic for today is impedance and admittance parameters. So let us look at what are impedance and admittance parameters, which is a part of actually two-port networks, which is a part of two-port networks. So let's see what is it. So first we'll define what is a port. Port is a pair of terminals. A pair of terminals through which a signal is fed or taken. It is called as a pair of terminals, is called as a port. And a network with a pair of terminals, that is one pair, that implies it has two terminals, is called a one port network, is called a one port network. Similarly, if you want to know, it is two port network, which is very useful. A two port network has four terminals or two pair of terminals. It has two pair of terminals. So it has two pair of terminals or four terminals is said to be a network which has two pair of terminals, or four terminals is said to be a two port network. So these two port networks are useful in construction of filters, attenuators, etc. Useful in construction of filters, attenuators, etc. So this is a port and a two port network. Now let us see. Let us consider a two port network like this. So this is a black box. There is a box that has any circuit in it, and it has a pair of terminals at the output and a pair of terminals at the input. So this pair of terminals wherein we give supply, and there is another pair of terminals which is V2 I2. So this is called as an input port, and this is called as an output port. So we name them as 1 1 dash, 2 2 dash. So current will enter this circuit through this one, and it will leave this circuit, and similarly it will enter this and leave this. So this is a two port network. This is a two port network. So 1 and 1 dash is the input port, and 2 and 2 dash is the output port. 2 and 2 dash is the output port. 1 and 1 dash is the input port. Right? So this is a two-port network. Now, so we have seen what is a port, what is a two-port network. Soumya, good evening. Srinivas, good evening. Vamshi, good evening. Welcome to Unacademy. Swarnasri, good evening. Welcome to Unacademy. Srinivas Nayak, good evening, sir. Good evening, Srinivas Nayak. So we have seen what is a two-port network. It has two pair of terminals. One is the input port, other one is the output port. Right? Now V1, I1, V2, I2 are the voltages and currents at the input and output terminals. Now based on these four parameters or the variables V1, I1, V2, I2, there are different types of parameters, namely the first one is impedance parameters. That is one of our topic for today. Impedance parameters. Second one, admittance parameters. Admittance parameters. Third one, ABCD parameters. ABCD parameters. Fourth one, hybrid parameters. Hybrid parameters. So impedance parameters are also called as impedance being Z, it is Z parameters. And admittance parameters is Y parameters. And ABCD parameters are also called as transmission parameters. You will also have inverse hybrid or G parameters also. So these, the other name for Z parameters is open circuit parameters. They are also called as open circuit parameters. We'll see why it is called as an open circuit parameters. Y parameters are called as short circuit parameters. Right? So these are the different names and these are the types of parameters we have. Different types of parameters based on the dependent and independent variable changes. Based on the dependent and independent variables. Based on the dependent and independent variables, we have these four types of major four types of parameters: impedance parameters, admittance parameters. So our interest of today is impedance and admittance parameters. We will see what are impedance and admittance parameters, and then I'll explain you some problems based on this. So I'll explain you some problems based on this. So first let us consider impedance parameters. Impedance parameters are also called as Z parameters. They are also called as open circuit parameters. They are also called as open circuit parameters. So impedance parameters or Z parameters or open circuit parameters. So before this, let me just tell you one thing. Some of the students were asking me about the clarity of the screen. So just listen to this. If you are watching it on your mobile, if this is the screen that you have on your mobile, please do click on the three dots that you have here. You have three dots at the top right corner. You have three dots. If you just touch your screen, you have three dots here. Just click on those three dots. There will be a pop-up. There will be a pop-up here like this. You'll get a pop-up wherein you have, I'll just see and write it. It is report, quality, second one, captions, play speed, playback speed, and so on. So in this, you just have to click this quality. Click on this quality. click on this quality. Click on this quality. Once you click on this quality, there will again be a pop-up. So you have a pop-up again, a small pop-up wherein you can find it has two. You'll find something like this: auto 144p, 240p, 360p, and so on. Just click on this 480p or the maximum value that you have. Click on this last one, whichever is the maximum that you can see. Mostly you can see this 480p. So click on this. Once you click on this, then you'll have a better quality. You'll have a better quality. All right. So let's look at impedance parameters or Z parameters or open circuit parameters. In impedance parameters, as I told you, we have four variables: V1, V2, V1, I1, V2, I2. V1, I1 are the voltage and current at the input port. V2, I2 are the voltages and currents at the output port. Shivakumar, good evening. Welcome to Unacademy. Next, from this, if we consider V1 and V2 as, if V1, V2 are dependent variables and I1, I2 are independent variables, if V1, I1 and V1, I1 are, sorry, V1, V2 are dependent and I1, I2 are independent, you can write them as, see, you have a two-port network here with pair of terminals at the output and pair of terminals at the input, right? So in this value is V1, I1, and this is I2, V2. So this is a two-port network, right? Now if I consider V1, I1 as V1, V2 as dependent variables and I1, I2 as independent variables, you can write it as V1 is equal to Z11 I1 plus Z12 I2. Similarly, V2 is equal to Z21 I1 plus Z22 I2. Or in other words, you can simply write this as V is equal to Z into I. That is, you can write V1, V2 in matrix form as V1, V2 is equal to Z11, Z12, Z21, Z22 into I1, I2. This is the matrix form. So these are Z parameter equations. What are these? Z parameter equations. Equation 1 and equation 2. And this is matrix form. Alright. So from this you need to determine what is Z11, Z12, Z21 and Z22. What is Z11, Z12, Z21 and Z22. You need to determine these values. So let us see how do you do that. So we know, I'll just write these values here. V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. From this, if I consider case 1, if I take case 1, if I consider, what happens? If I2 is equal to 0, first we'll see what is I2 is equal to 0. Current is equal to 0. What is current is equal to 0? Open circuit, right? What is current is equal to 0? It is an open circuit. and we are saying I2 is equal to 0. What is I2? Current at the output port. Therefore, open circuit output port, open circuit output port. Now if you apply this condition, if you apply this condition in this equations 1 and 2, what will happen if I2 is equal to 0 in equation 1? V1 is equal to Z11 I1 plus Z12, I2 value is 0. So this is 1. This will give you V1 is equal to Z11 I1. What is Z11 from this? Z11 is equal to V1 by I1. Z11 is equal to V1 by I1. What is the unit of impedance? Ohms. And this is called as, this is named as V by I is impedance. So driving point input impedance. Driving point input impedance. Now what is this driving point is, you have two types, driving point and transfer. If the ratio of this voltage and current is at the same port, you can write it as you name it as a driving point impedance. If it is V2 by I2, V2 and I2 both are also at the same port. If the ratio is always at the same port, you will write it as driving point. And V1 and I1 belong to input, so it is driving point input impedance. Right now, in the same way, if you apply I2 is equal to 0 in the second equation, it is V2 is equal to Z21 I1 plus Z22 into I2 value is 0. Z22 into I2 value is 0. If I2 value is 0, V2 I2 value is 0, V2 is equal to Z21 into I1. Now what is Z21 is equal to V2 by I1. I'll write this in the next slide. Z21 is equal to V2 by I1. Now if you observe this ratio, it is not the ratio at the same port. This is not the ratio at the same port. See, V2 is the voltage at the second port, I1 is the current at the first port, but V by I is a impedance. So unit is ohms. So you have something called as transfer you have something called as transfer impedance. This is called as transfer impedance. And in transfer impedance, you have two types of transfer impedances. One is forward transfer impedance and the other one is reverse transfer impedance. And this is the forward transfer impedance. This is called as the forward transfer impedance. So we have seen the case when I2 is equal to 0. What is I2 is equal to 0? Open circuit the output port, and we have obtained what is Z11 and Z21. Now similarly, if I consider I1 is equal to 0, second case 2. Case 2, what is case 2 is, if I1 is equal to 0. What is I1 is equal to 0? Current is 0. Current is 0 is open circuit. So which current is 0 here? First port current is 0. Therefore it is open circuit port 1. Open circuit port 1, or port 1 is open circuited. Now what are the equations corresponding to that? V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. From this, what can you write? V1 is equal to Z11 I1 value is 0 plus Z12 into I2. Similarly, V2 is equal to Z21 into 0 plus Z22 into I2. From this, what can you write? V1 is equal to Z12 I2. Similarly, V2 is equal to Z22 I2. Finally, you can write it as can write Z12 is equal to V1 by I2, and similarly Z22 is equal to V2 by I2 ohms. And what are these named? Now let us see how are they named. So what is Z12 called as? Z12. So Z12 is called as, what is Z12 called as? It is a ratio at a different ports. So it is a transfer impedance. And what is the ratio? V by I. So it is a Augustus, good evening, transfer impedance. It is a transfer impedance, and it is V1 by I2. So it is a reverse transfer impedance. So Z12 is reverse transfer impedance. And what is Z22? It is V2 by I2. What is V2 by I2? Ratio of voltage to current at the same port. So ratio of voltage to current at the same port. So it is called as driving point output, or you can just call it as output impedance, or it is driving point output impedance. It is driving point output impedance, right? So it is transfer impedance and driving point output impedance. So let us write all z parameter values at one place. Z11 is equal to V1 by I1. When do you get this? When I2 is equal to 0. Similarly, Z21 is equal to V2 by I1. When do you get this? When I2 is equal to 0. Similarly, Z12 is equal to V1 by I2. When do you get this? When I1 is equal to 0. Similarly, what is Z22 is equal to? Chandrakiran, good evening. It is V2 by I2. When? When I1 is equal to 0. And what is this named as? It is input impedance or driving point input impedance. This is forward transfer impedance. Forward transfer impedance. This is reverse transfer impedance. And Z22 is output impedance, because V2 I2 is the ratio at the output port. So this is output impedance. So these are called as Z parametric equations. Z parametric equations. And when do you get these values? When you get these two values, you can find these two values when I2 is equal to 0, and you can similarly find these values when I1 is equal to 0. What is I1 is equal to 0 or I2 is equal to 0? It is open circuit port 2 or output port. Here open circuit port 1 or input port. So because you have this open circuit, you are getting these parameters by open circuiting. These are also called as open circuit parameters. So these are also called as open circuit parameters. These are also called as open circuit parameters, right? So we have seen Z parametric equations. V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. And we have also written its matrix form. And we have found what are Z11, Z12, Z21, Z22. When do we get them? And also What are they? Input impedance, forward transfer impedance, reverse transfer impedance, and output impedance. Now let us consider one problem on this. So the question given is, find Z parameters for the given network, and the network is this one. A T network is given, simple T network. Because we can solve this by using some other methods. Let's say this is 4 amps, 5 ohms, sorry, 4 ohms, 5 ohms, and 6 ohms. And this is I1 plus minus V1 plus minus V2, and this is, let us say, I2. Now how can you find this? The solution can be found in two ways. One is, first we will write in the first step, we will write, because they are, it is given Z parameters, or sometimes he may also ask you as find open circuit parameters, nothing but Z parameters. So the very first step that we have to do is write Z parametric equations. V1 is equal to Z11 I1 plus Z12 I2, and then similarly V2 is equal to Z21 I1 plus Z22 I2. This is the first step. Now in the second step, what you will do is case 1. First we will consider case 1. What is that case 1? It is if I2 is equal to 0. What is that I2 is equal to 0? Sorry, open circuit. If I2 is equal to 0, open circuit port 2. So we will open circuit port 2 and give supply to the port 1. So we will open circuit port 2. So when you open circuit this port 2, what is going to happen? This will be I1. This is V1, 4 ohms, 5 ohms, 6 ohms. V2 is present. But what is the value of I2 here? I2 is 0. What is the value of I2? I2 is 0. Now when you apply KVL to this loop here, if you consider this as the loop I1, and if you consider this I1 current, it will reach this point and move towards the 6 ohm. It does not go into this 5 ohm resistor because it is an open circuit. So what is V1 is equal to, you will get it as 4I1 plus 6I1. So from this you can write V1 is equal to 10I1, or V1 by I1 is equal to 10. Now what is V1 by I1? We already know that V1 by I1 is Z11. V1 by I1 is Z11. So we have got what is Z11. Next, write the another equation. You have two more equations. Only I2 is 0. What are the rest of the things that are there in this? I1, V1, V2. We have written relation between V1 and I1. Next, you need to write the relation between V2. What is V2? V2, if you observe, it is actually the voltage across 5 ohm and 6 ohm. But because the current in this 5 ohm is 0, and what is the current flowing in 6 ohm resistor? It is current flowing in 6 ohm resistor is I1. So you can write V2 is equal to 6 into I1. So what is V2 by I1 is equal to 6 ohms. So what is V2 by I1? It is Z21 by is equal to V2 by I1 is equal to 6 ohms. So this is the another value. So this is another value that you have. So in one case you will get two values. When I2 is 0, you will get two ratios, V1 by I1 and V2 by I1. Next, consider third case. Sorry, case 2, third step. Case 2, second case. What is the case 2? What was case 1? When if I2 is equal to 0. If I2 is equal to 0. If I2 is equal to 0 was the case 1. Now next case 2, if I1 is equal to 0. If I1 is equal to 0. What is I1 is equal to 0? Open circuit port 1 or input port. Anything, right? Port 1. So let's draw that. So you will open this first port and there is a supply that is given to the second port. This is the second port. Let us call this as 1 1 dash, this as 2 2 dash to be more clear. So this is the voltage V2 that is applied across this. This is 4 ohms, 5 ohms, 6 ohms, and V1 is also present here, V1, but I1 is 0 and you have I2 already here. So for this also you can apply this K equation. This is I2. If you apply KVL, if you I2 also will not go to this 4 ohm resistor because it is open. So what can you write? V2 can be written as V2 is equal to, apply KVL, 5 into I2 plus 6 into I2. There is only 6 I2 current that is flowing in this 5 and 6 ohms because I1 is 0. I2 is the only current that is flowing. So you can write V2 is equal to 11 I2 or V2 by I2 is equal to 11 ohms. What is V2 by I2? It is Z22. What is V2 by I2? It is Z22. Now, what is the other equation that you can write here? You can write the other equation. See, what is the other equation? V1. See, you have written V2, I2. I1 is already 0. You have one more variable V1. So, what is V1 is equal to? V1 is actually the voltage across 4 ohm and 6 ohm. But the voltage across 6 ohm will 4 ohm will be 0 because I1 is equal to 0. So, what is V1 is equal to? You can write V1 is equal to 6 into I2. Therefore, what is V1 by I2 is equal to 6 ohms. So, therefore, Z12 is equal to V1 by I2 is equal to 6 ohms. V1 by I2 is equal to 6 ohms. So, these are the four values that you have obtained for Z parameters. So, what are the total Z values? We can write it as, for the given network, for given network V1, V is equal to Z into I, right? So what are V? V1 and V2 is equal to, what are these values? Z11, Z12, Z21, Z21, Z22 into I1, I2. So you can write this as V1, V2 is equal to, what are the values of Z11, Z12, Z21, Z22? Just write them. Z11 10, Z21 6. This is 10 and this is 6. Similarly, Z22 11, Z12 6. So this is what you can write it. So these are the Z parameters. That is what is that. You can write Z11 is equal to 10 ohms. Z12 is equal to Z21 is equal to 6 ohms. And Z22 is equal to 11 ohms. So these are the required Z parameters of the given network. So this is how you have found the Z parametric equations. Now let us see once again what have we done. So let's see what have we done just now. First, let us see the given network. So this was the given network. So to this network, we were asked to find open circuit parameters or Z parameters. We were asked to find open circuit parameters or Z parameters. So we have considered first what are Z parametric equations. Then we have considered case 1, that is I2 is equal to 0, which implies open circuit port 2, or port 2 is open circuited. Then you apply KVL in this. Just apply nothing you are doing here. You are just applying KVL. Just you will apply KVL. And when you apply this KVL, you'll get V1 is equal to 4I1 plus 6I1. So you'll get V1 by I1 Z11 is equal to 10 ohms. This is 10 ohms. And similarly, if you apply V2 is equal to voltage across second port is V2, but here 5 ohm resistor, there is no current, I2 is 0. Therefore, actually V2 should be 5 into I2 plus 6 into I1 plus I2. But because I2 is 0, second port is open and there is no current, you'll get V2 as 6 into I1. So that's how you'll get Z21. Similarly, you'll consider the next case, that is I1 is equal to 0, and that is open circuit port 1, and you'll apply KVL to the second port, and also write the equation for the first port. V1 is equal to 6I2, so you'll get Z22 value and Z21 values. So that's how you can write these Z parameters in matrix form like this. So you'll get Z11 is equal to 10 ohms, Z12 is equal to Z21 is equal to 6 ohms, Z22 is equal to 11 ohms. So this is how you will determine Z parameters of a given network. So we will also consider Y parameters. Then we shall solve the different types of questions, or the different questions based on Z and Y parameters. So let us now consider Y parametric equations. Yes, Chandrakiran, good evening. SVS Online, good evening. Abhishek, thank you Abhishek. Jayant, good evening. So let us consider Y parameters or admittance parameters. Let's write it as admittance parameters. Let us consider admittance parameters. Admittance. Good evening, Jayant. Admittance parameters. Welcome to Unacademy. So admittance parameters or Y parameters, or these are also called as short circuit parameters. Yeah, good evening, Srilata. So admittance parameters or Y parameters or short circuit parameters, right? So admittance parameters are also called as Y parameters or short circuit parameters. So we have already seen what are the admittance parametric equations, impedance parametric equations. Likewise, you also have admittance parametric equations. Let us consider a two-port network like this with a pair of terminals at the input and pair of terminals at the output. So here we have voltage V1, current I1, output voltage V2 at the output port, V2 and I2. So let us name this port as 1 1 dash, this as 2 2 dash. Good evening, Srilata, welcome. So this is a two port network, right? So the admittance parametric equations are, in this case, The dependent variables are I1 and I2, and independent variables are V1 and V2. So you can write it as I1 is equal to Y11 V1 plus Y12 V2. And similarly, I2 is equal to Y21 V1 plus Y22 V2. Y21 V1 plus Y22 V2. So you can also write this as I is equal to Y into V in matrix form. Or you can write this further as I1 I2 is equal to Y11 Y12 Y21 Y22 matrix multiplied by V1 V2, right? So from this you can find the y parameters as, let us consider I1 is equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. So case 1, how do you determine y parameters is, first let us consider if V2 is equal to 0. What is voltage 0 first? What is voltage is equal to 0? It is a short circuit. Now what is V2 is equal to 0? It is short circuit port 2. So when I consider V2 is equal to 0 in these two equations, let us call this as 1 and 2. From 1, if I substitute V2 is equal to 0, I1 is equal to Y11 V1 plus Y12 V2. V2 is 0. So I1 is equal to Y11 V1. What is Y11 is equal to I1 by V1 mho admittance units, right? So Y11 is equal to I1 by V1, and this is named as, the ratio is between I1 and V1. It is input admittance. It is input admittance or driving point input admittance, and y11 is equal to I1 by V1, which is equal to y11 is units are mhos. And from equation 2, if you consider, from 2, if V2 is 0, you can write it as I2 is equal to y21 V1 plus y22 V2 value is 0. So from this you'll get I2 is equal to y21 V1, and from this you can write what is y21 is equal to I2 by V1. So it is a ratio at the different ports. So it's a transfer impedance, and it is I2 by V1. Therefore it is forward transfer impedance. So it is a, forward transfer admittance. Forward transfer admittance. And the units are mho, I2 by V1. This is when V2 is equal to 0. Similarly, we'll have case 2. So first let us write the equations. I1 is equal to y11 v1 plus y12 v2, and I2 is equal to y21 v1 plus y22 v2. In this, if you consider case 2, what is case 2? First v2 was 0. Now when v1, if v1 is equal to 0, what is v1 is equal to 0? It is also short circuit. Short circuit v1 belongs to port 1, right? So short circuit input port or port 1, short circuit port 1. So when you short circuit port 1, substitute this in this first equation, you'll get I1 is equal to y11 into v10 plus y12 v2. Similarly, in this, if you substitute, I2 is equal to y21 into 0 plus y22 v2. From this, what can you write? I1 is equal to y12 v2, and from this I2 is equal to y22 v2. What is y12 is equal to I1 by v2. Similarly, what is y22 is equal to I2 by v2. So what are these values? These are admittance values. So this is transfer admittance, reverse transfer admittance, and this is driving point output admittance. And what are these values here? Admittance values, units are mho. So this is reverse transfer admittance, and this is driving point output admittance. So this is forward transfer admittance and input admittance. So let's write all these at one place. So what is y11 is equal to I1 by v1? When do you get this? When v2 is equal to 0. Similarly, what is y21 is equal to I2 by v1? When do you get this again? When v2 is made 0. Similarly, what is y12? It is I1 by v2. When do you get this again? When v1 is made 0. What is y22? It is I2 by v2. And how you get this value? When you make v1 is equal to 0. And what is this y11 called as? Driving point input admittance. And I2 by v1, forward transfer admittance. Or I1 by v2, reverse transfer admittance. And I2 by v2 is, it is output admittance. And when do you get this? When v2 is equal to 0. This also when v2 is equal to 0. And these values you get when v1 is made 0. What is v2 is equal to 0 indicates? Short circuit port 2. And what is v1 is equal to 0? Short circuit port 1. So this is about admittance parameters. Because you are getting these parameter values when you short circuit input and output ports, so this is also named as short circuit parameters. short circuit parameters. So let's see once again. So you have this two port network, and here also you have the same two port network. Pair of terminals at the input port and a pair of terminals at the output port. Similarly, pair of terminals at the input port and pair of terminals at the output port. So what is here? It is V1, V2, I1, I2. This is I1, I2, V2 and V1. What is the first case? Case 1. What is case 1? V2 is equal to 0. What is V2 is equal to 0? Short circuit this. That is V2 is equal to 0. When V2 is equal to 0, what are the other parameters variables you have? V1, I1 and I2. From this what you will write? Y11, that is 1 I1 by V1. Next Y21, that is I2 by V1. When you make V2 is equal to 0. Similarly consider case 2. What is case 2? It is V1 is equal to 0. What is V1 is equal to 0? Short circuit port 1. So when you short circuit this port 1, what are the rest of the variables that you have? V2, I2 and I1. So what is that? What are the ratios that you get? One is Y22. What is Y22? I2 by V2. And what is the other one? Y12. What is Y12? I1 by V2. And the units are mho. So this is a two port network. This is a two port network. And what does this figure indicate? It is when V2 is equal to 0. And what does this figure indicate? When V1 is equal to 0. So this is what you have to do in order to find Y parametric equations. So let us consider one problem that we have considered previously and try to solve the given problem. So the question is, determine Y parameters or short circuit parameters for given network. So let us take these values, the same values that we have considered, 4 ohms, 5 ohms, or you can take any other value, that does not matter. I1, V1 and this is V2 and I2. So what are we asked to find? Y parametric equations. So what you will do is first write Y parametric equations. What are they? I1 is equal to Y11 V1 plus Y12 V2. Next I2 is equal to Y21 V1 plus Y22 V2. So in the second step, what you have to do is, in second step we will take case 1. What is case 1? Case 1 is when V2 is equal to 0. What is V2 is equal to 0? short circuit port 2, short circuit port 2. So if you short circuit port 2, what will happen? Just draw the circuit. This is port 2. We need to short circuit. So just short circuit this port 2. This is V2 is equal to 0, 5 ohms, I2, I1, V1, 4 ohms and 6 ohms. So what is the ratio that you need to find when V2 is equal to 0? When V2 is 0, you will get I11 is equal to I1 by V1 if you observe these two. Next, Y11 is equal to I1 by V1. Y21 is equal to I2 by V1. This is the ratio that you need to obtain. That means you need to write a equation between V1 I1 and V1 I2. So let us consider this circuit in the next slide and try to do that. So let's apply KVL equation, or first simplify. These two resistor, if you observe, are in parallel. So 5 into 6 by 5 plus 6, that is 5 in parallel with 6. This is 30 by 11, right? So let's write it as 30 by 11. And this 30 by 11 is in series with 4. So it is 30 plus 44 by 11. 74 by 11 is the total resistance. So R total is equal to 74 by 11. So what do you get? That V1 is equal to I1 into R total resistance. So V1 is equal to I1 into 74 by 11. From this, can I write I1 by V1 is equal to 11 by 74 more? What is I1 by V1? It is Y11. It is Y11. Similarly, what is the next relationship that you need to? I1 by V1 is complete. Next, I2 by V1. So you need to write an expression for I2. So let us consider the same circuit in the next slide once again. So just take it this way. Now let us take some current is flowing in this as I2 dash, where I'll say I2 dash is equal to minus I2. Now if you observe 5 and 6 are in parallel, I2 dash is the current flowing in 5 ohm resistor. So can I write it as I2 dash is equal to total current I1 into current in any parallel branch is equal to total current into opposite branch resistance by total resistance. Opposite branch resistance by total resistance. What is V1 is equal to? Already we got V1 is equal to I1 into 74 by 11. So this is I2 dash. I2 dash is equal to what? Minus I2 is equal to I1 into 6 by 11. But we already know V1 is equal to I1 into 74 by 11. V1 is equal to I1 into 74 by 11. Now just take these two equations and you need to find the ratio of, what is the ratio that you need to find? I2 by V1. So you can take I2 by V1 is equal to 6 by 11 I1 by 74 by 11 I1. You can cancel this. It is minus 6 by 74 more. What is this? I1 by I2 by V1, it is Y21 is equal to. So Y21 value got it as. Right. So this is the value. So this is Y11 and this is y21. Next, similarly, you can also find case 2. What is case 2? When v1 is equal to 0. When v1 is equal to 0. Similarly, if you consider v1 is equal to 0, yeah, let us consider this circuit and make v1 is equal to 0. If this is the circuit, v1 is equal to 0. What is v1 is equal to 0? This is the case 2. When v1 is equal to 0. When v1 is equal to 0, what is that? You'll get I1 is equal to y12 v2 and I2 is equal to y22 v2. So what are the values that you'll get? Y12 is equal to I1 by v2, y22 is equal to I2 by v2. So these are the two values that you need to find when you make v1 is equal to 0. So this is v1 is equal to 0, short circuit. When you short circuit this, 4 and 6 will be in parallel. So 4 in parallel with 6 will give you 4 into 6 by 4 plus 6. 4 into 6 by 4 plus 6. So what is that value? 4 6 are 24 by 10. So it is 2.4. Now this 2.4 will be in series with 5. So 2.4 plus 5 will give me 7.4 ohms as the R total value. So what is V2 by V2 is equal to, what is R total? 7.4 into R, sorry, 7.4 is the R total value into I2. So from this you'll get I2 by V2 is equal to 1 by 7.4 more. What is I2 by V2? It is Y22. So I2 by V2 is equal to Y22. Y22 is I2 by V2, which is 1 by 7.4 more. Right? The next value that you need to find is I1 by V2. This is I1 by V2 that you need to find. So what is I1? Let us consider this current as I1 dash. This current as I1 dash. What is I1 dash is equal to? Is equal to minus I1. So let us consider this circuit in the next slide. So I1 dash is equal to I1 dash is equal to minus I1. So what is I1 dash is equal to total current I2 into I1 dash is the current in parallel branch. So I1 dash is equal to total current I2 into opposite branch resistance 6, because I1 dash is the current in 4 ohm resistor. Its opposite branch is 6 ohm resistor by 6 plus 4. Already we have one equation. What is I1 dash is equal to? Minus I1 is equal to I2 into 6 by 10. And we already have V2 is equal to 7.4 I2. Divide these two. So I1 by V2 is equal to minus 6 by 10 I2 by 7.4 I2 will give me minus 6 by 74 more. What is this value? Y12. So this is Y12. We already got Y22 and we have already found what is Y11 and Y21. So this is how you will determine Y parameters of the given network. You can also solve the same circuit by using another method. I'll also tell you that method. Let us consider this circuit, and to this circuit consider two loop equations. Let us call this as I1. Let us call this as I2. So apply KVL in both loops. apply Kirchhoff voltage laws. You will get V1 is equal to 4I1 plus 6 into, this is 4I1 plus 6 into I1 plus I2. I1 plus I2. Similarly, so you can write V1 is equal to 4I1 plus 6I1, 10I1 plus 6I2. Similarly, you can write in loop 2, this is in loop 1. Similarly, in loop 2, second loop, if you write V2 is equal to 5I2 plus 6 into I1 plus I2. So what is that you'll get? V2 is equal to 6I1 plus 11I2. So these are the two equations. So these are the two equations that we got. So from this you can write V1 is equal to, Shivakumar, thank you, 10I1 plus 6I2. V2 is equal to 6I1 plus 11I2. So you can write V1 V2 is equal to 10 6 6 11 into I1 I2. So you can write this as I1 I2 is equal to, from this if you can find I1 I2 is equal to 10 6 6 11 inverse matrix into V1 V2. This is another way of determining. So what is A inverse? You'll write adjoint and all, but if it is a 2 by 2 matrix of A B C D, if A is 2 by A B C D, if A is equal to A B C D, then A inverse is 1 by AD minus BC D minus B minus C A. This is what you'll write it. So from this you can write it as I1 I2 is equal to 1 by, this is AD 110 minus BC 36 D 11 minus 6 AD minus BC D minus B minus C A into V1 and V2. So you just need to multiply 110 minus 36 will give you 74. So it is, you'll get this matrix values as 74 by, sorry, 11 by 74 minus 6 by 74 minus 6 by 74 and 10 by 74 into V1 V2 and I1 I2. So these becomes the admittance parameters. You just compare this with I1 I2 is equal to Y11 Y12 Y21 Y22 into V1 V2. From this you can write Y11 is equal to 11 by 74, Y21 is equal to minus 6 by 74, Y12 is equal to minus 6 by 74 and Y22 is equal to 10 by 74. More. So these are just the values of Y1, Y2, Y11, Y12, Y21, Y22. So if you want, you can just compare them with the values that we have got already. So what is Y12 here? It is 6 minus 6 by 74. Minus 6 by 74 if you observe. Similarly, Y22, it is 1 by 7.4 or 10 by 74. So you can just see 10 by 74. And next, you can also check Y11, 11 by 74, 11 by 74. So this is another method of solving that. So you can use this method, or you can also use the other method of short circuit open circuit method, or you can also use this method of solving the circuit. So today we have seen, I'm sorry, what are Z parametric equations, Z parameters. They are also called as impedance or open circuit parameters. And we have seen what are Y parameters or admittance parameters or short circuit parameters without a dependent source. But if there is a dependent source also, you can solve if you know fundamental KVL, KCL, mesh analysis, network reduction techniques perfectly. So we have also seen some problems, numericals today. So that's all for today. We can also will do the next parameters in the next class. So as I tell you, we have India's #1 study channels, Creatrix Gate, Unacademy Gate, Unacademy Gate CE, Unacademy Gate Telugu, Unacademy SSCJE, Unacademy Computer Science, Unacademy Gate Questions, Electrical Junction, Engineering Foundation, Pathshala, and Unacademy Semester Exams. So please do like this video, share this video, use my code to get 10% subscription or 10% off on your next subscription, and do subscribe to Unacademy and click on this bell icon to get notification of my classes. Once again, thank you all. Thank you Shiva, thank you Soumya, thank you Karthik, thank you Abhishek, thank you Jayan, thank you once again everyone for joining me this session. Thank you.